Okay, let's look at the scatter plot section. It says find the equation, find the R value, determine whether it's strong or weak correlation, and if it's positive or negative correlation. So we need to turn our diagnostic on in order to find the R value. So we had second, 0. You gotta toggle down till you get to diagnostic. It's in alphabetical order. Diagnostic on is what we're looking for. Here you go. And then you hit enter, enter till you see done. Then you know it's on. Now we need to go and turn on stat plot. So you hit second, y equals, enter. Make sure that the cursor's on top of the on. Hit enter again. See, now it's on. Now we're going to go to stat, enter, and put in our numbers. We have 1, 2, 3, 4, 5, 7 on the left side. So 1, 2, whoops, back, 2, 3, 4, 5, 7. And then on the right side in list 2, we're going to put in 3, 3, 5, 7, 6, 9. Check to see if they're even. That means you did the right list length. And now we're going to go figure out what the equation is. So we hit stat, calc, go down to linear regression, enter, 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 enter. So we have a slope of 1.028, so we're going to round out to 1.03. Y equals 1.03 x, and our slope, our y-intercept is 1.7. Okay. Now it says what's the R value. You see here that the R value is 0.947, so we're going to round that to 0.95. Remember, the strength of the correlation has to do with how close it is to either positive or negative 1. This is a strong correlation, so we'll circle that. And the fact that the R value is positive means that it's a positive correlation. Okay, so looking at sequences, it says use the formula T sub n equals T sub 1 plus D times n minus 1. What does D stand for? D stands for the common difference. Common difference. On the test, that's going to be a fill in the blank, so you have to actually know that. Common difference. Okay. And then what does T sub 1 stand for? Remember, T means term. The subscript 1 means that's the first term. So first term. And then it says find T sub 17. So we want to find the 17th term for this sequence. So how do we do that? We need to use this equation here. T sub n, the n is going to be 17, that's our x. That's the thing we decide, right? Independent variable. And then T sub 1 means first term. That would be negative 12 plus, what's our common difference? Common difference is negative 12. If we go from negative 12 to negative 8, we see it's 4. If you're not sure, you can always take the second number and subtract the first number from it. See, positive 4. Remember to pay attention to your signs. Take the second number, subtract the first number, which is a negative 12. Negative 8 minus a negative 12 gives you positive 4. So a common difference is 4. And remember, this part always stays the same, n minus 1. Okay? Then I'm going to put this into my calculator. This T sub 17 or whatever this ends up being is really your y, right? So I just go to y equals, and I put in negative 12 plus 4, open parentheses, x minus 1, and then I'm going to go look in my table for the 17th term. The 17th term right here. 17th term is 52. So the answer is T sub 17 equals 52. Okay. Okay, looking at parallel and perpendicular lines. It says given y equals 3x minus 9, write an equation of a perpendicular line, and write an equation of a parallel line. So on the test, this is going to be a fill in the blank where they give you your y-intercept. So it'll be like y equals, have a blank, x plus, let's say, 5. You need to tell us what would the slope be of a perpendicular line to this line. So remember, the perpendicular means that it's going to be the reciprocal and opposite sign, right? Reciprocal is a fancy word for saying flip it. So if I have 3, any whole number can just be put over 1 to make a fraction, right? So if I flip that, it becomes 1 over 3. So my answer here will be 1 over 3x plus whatever they have here for your y-intercept. That's a 3. Oh, that looks terrible. Okay, I'll put it here. 1/3 goes into that blank. Then it says write an equation of a parallel line. Remember, a parallel line has the same slope, same sign. Same slope, same sign. So, again, on the test, I'm moving it down here. On the test, you'll have fill in the blank, something x plus, I don't know, let's say 6. Same slope means I just put 3 here. Same slope, same sign. Number 2 says, given this graph, write an equation of a perpendicular line. So I have this line here. If I want it to be perpendicular, I have to find out what the slope is. So I'm going to count the slope from these points here to go up 1, 2, over 1, 2. So the slope is 1, right? Slope is 1. And the y-intercept is 2. So my equation is y equals x, or you can say 1x plus 2. So I want a line that is perpendicular to that line. So my slope's going to be, if I have 1, 1 is just 1 over 1, right? I flip that, I still have 1, and I change the sign. So it's going to be a slope that's negative 1x plus some y-intercept. Since they didn't tell me what point it has to be going through, I can choose any y-intercept I want, or I can keep this one. It'll still be perpendicular. I'll choose 4. I think on the test it gives it to you, but I can't remember. Okay, and then so that was for the perpendicular line to this line here. Now I want the line that is parallel to, again, the same line from the graph. This was the line. So parallel means it has to have the same slope. So I'm still going to have 1x, but it cannot have the same y-intercept because then it'd still be the same line. So I choose some other y-intercept. I'll choose negative 3. But I think on the test it tells you what the y-intercept is going to be. So I have y equals 1x plus negative 3. Okay, looking at transformations. Y equals 3 times x minus 2 plus 7. So it says, did the line shift up or down? Remember, this number on the outside of the parentheses tells us whether shifting up or down because that is our y-intercept. So this is positive, so it shifts up. And then here, inside the parentheses tells us about whether it shifted left or right. Okay, left or right. Remember, in the parentheses it does the opposite of what it looks like. So I would think a negative 2 would make me move left on the number line. So that means I'm actually going to move right. You can think of it like I said in the previous video, that the parentheses tell me, since parentheses are left and right. So parentheses mean I'm going to move left or right. Okay, what's in the parentheses tell me if I'm going to move left or right. And then lastly it says, was the line vertically or horizontally stretched or compressed? The number out here in front, you can think of that as like the slope. The bigger it is, then the more stretch we get. The smaller it is. If it's a fraction, then it's going to be a compression. So this is going to be a vertical stretch. Okay? And then I look at the next one. Given y equals 1/2, x plus 7 minus 3. Again, I'm looking here at what this is. We can look at that as being the y-intercept. and that y-intercept tells me whether it's going up or down. The line shifts down, right, because it's negative. And then it says, did the line shift left or right? Again, the parentheses tell me that I'm moving left or right because my parentheses are to the left and to the right of these numbers inside. So I'm going to move the opposite of what I would think. This is a positive. I would think it would move to the right because that would be positive on the number line. But it's going to be opposite, so it's going to move left. Shift left. And then lastly, out here in the front, it says, was this vertically or horizontally stretched or compressed? A fraction tells me that I have compression, and because it's out here in front of the parentheses, it's vertical. So it's a vertical compression. Last, it says graph the linear parent function y equals x, and then graph y equals 2 times x plus 1 minus 3. So my linear parent function, remember, is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. Same here. Negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, negative 5, negative 5, negative 6, negative 6, negative 7, negative 7, negative 8, negative 8, negative 9, negative 9, negative 10, negative 10. That's my linear parent function. If you're not sure, go to the y equals, put in y equals x, right? Because that's what we just grabbed. Look at your table. See? 8, 8, 7, 7, 6, 6. That's a linear parent function. Now we're going to graph y equals 2x plus 1 minus 3. I'm going to make this easier by distributing. Remember, distribute, so I have parentheses 2x plus 2 minus 3. Now I'm going to combine my terms. I get 2x minus 1. So I'm going to graph this. So if I make a t-table, I put 0 in for here. 2 times 0 is 0, minus 1 is negative 1. 1 times 2 is 2, minus 1 is 1. Or I could just put this in my calculator and look at all the values, which is what I'm going to do now, because that will take less time. So I'm going to put in 2x minus 1. I'm going to go look at my table. There we have it. So I have 0, negative 1. That was the first number that I did here. 0, negative 1, and then 1, 1, over 1, up 1. Actually, I should use a different color. I'll go back and do that in a different color. So I have 0, negative 1. I have over 1, up 1. I have 2, 3, go over 2, up 3. I have 3, 5, go over 3, up to 5, 1, 2, 3, 4, 5. I'm just doing the positive side right now. And then I have 4, 7, go over to 4, up to 7. 5, 9, and 6, 11 goes off the tables, off the graphs. I'm not doing that. I'm going to go back to my negative numbers. So I had negative 1, negative 3. So go back 1, go down 3. Negative 2, negative 5. Go back 2, go down 5. 1, 2, 3, 4, 5. Negative 3, negative 7. Go back 3, go down to 7. Negative 4, negative 9. Go back 4, go down to 9. And that's as far as I can go and still stay on the graph. So that's how I graph it. And preferably, these are equations. I'll make it into a line. That's it.